Hi students, welcome to Inside Physics. Today we will see some topics in electric charges and fields. Okay, electric charges and fields. So first of all, what is a charge? So a charge is a fundamental property of a body by which it actually produces and experiences electrical effects and magnetic effects both. Okay, this is the fundamental definition of charge. So charge is represented with q. Now we see what are the general characteristics of a charge. If a body is considered to be a negatively charged, that means it is having excess of electrons. If a body is considered to be positively charged, that means it is having deficiency of electrons. The charge is either positive or negative. Okay, and a charge is a derived quantity and the dimensional formula is AT. Dimensional formula of charge is AT. Okay, see, when there is a deficiency of electrons, I told you that body is negatively charged, and if there is excess of electrons, the body is negatively charged. If there is a deficiency of electrons, the body is positively charged. Okay, see, what is the unit of charge? See, unit of charge is coulomb. It is represented with C. Unit of charge is coulomb and it is represented with C. See, this is a SI unit. Coulomb is a SI unit. And CGS unit of charge is CGS unit of charge is stat coulomb. Stat coulomb, or we can say ESU, electrostatic unit. Okay, one electrostatic unit is equal to 1 by 3 into 10 to the power of 9 coulombs, and one electromagnetic unit is equal to 10 coulombs. 10 coulombs. Okay, see, this is the units of charge. See, when a body is positively charged, that means it has deficiency of electrons, the body will lose some weight. If a body is negatively charged and it gains some weight because of excess electrons. Okay, see, we will see with one example how a body will gain the weight or lose the weight. Okay, if two bodies, two identical spheres A and B, which is A is positively charged and B is negatively charged, are connected with a conducting wire. Now the negatively charged, from negatively charged particle, the electrons will flow from B to A. In this process, the electrons will be added to this positively charged particle. So by this, the excess mass of the electrons will be added up to object A. So object A will gain the mass and object B will lose the mass. Okay, so this is about charge. Now we will proceed to what is a quantization of charge. quantization of charge. What is quantization of charge? Charge is available in discrete values. That means it is available in the multiples of electron charge. That is, we can write Q is equal to plus or minus Ne, where E is electronic charge and N is integer. So we know that charge of electron is equal to 1.602 into 10 to the power of minus 19 coulombs, right? So whenever there is a charge, it is available in multiples of electronic charge only. That is called quantization of charge. N, we can say N is equal to 1, 2, 3 up to so on. So if it is plus, it is a positive charge. If it is minus, it is a negative charge. Okay. See, in quantization of charge, if suppose there are N1 protons and N2 electrons of having different objects. If object A is having N1 electrons and object B is having N2 protons. So what is the difference of charge? The difference of charge we can write it as N1 minus N2 into E. So electron and proton both are having same charge, but the difference it comes is the number of protons and number of electrons. In this way, the charge is quantized. Whenever we say some charge is present, it should be in the multiples of electronic charge only. Okay. So for better understanding of quantization of charge, we will see a small example of how to calculate the charge. See, I will give you a small question and we will solve that. With that we can understand what is exactly quantization of charge. See, calculate the charge present on 100 cc of water due to protons. Calculate the charge present on 100 cc of water due to protons. See, we know that a water molecule has a gram atomic weight of 18. So 1 mole of substance will have how many molecules? 1 mole of substance will have 6.023 into 10 to the power of 23 molecules. In this way, 100 cc of water will have how many moles? Means 1 mole of water will be equal to 1 gram atomic weight of water. That means how many moles are there in 100 cc of water? Means 100 by 18. This is number of moles. Okay. See, one water molecule will contain 10 protons. One water molecule will contain 10 protons. So we have the data now. We will calculate the charge present on 100 cc of water due to protons. See, the charge Q will be equal to 100 by 18 into 6.023 into 10 to the power of 23, the number of molecule present in 1 mole of water, and into 10, the number of protons present on each molecule, into charge of electron minus 19. So this will be the charge present on the 100 cc of water. So if we calculate, we will get this one as around 5.34 into 10 to the power of 7 coulombs. See, this example gives us about the quantization of charge. how to calculate the charge present in a molecule or body or any material. So it should be compulsorily in the multiples of electronic charge only. Okay. So this is about quantization of charge. So next we move to law of conservation of charge. Law of conservation of charge.